Good afternoon. I'm Courtney Carr, the Director of Marketing and Education for IAPD. Thank you for joining today's e-training webinar, See-Through Plastics, COVID-19 Training, presented by Greg Hallam of PLASKOLITE. During the presentation, you may submit questions into the Questions tab on your webinar toolbar, and we will answer them at the conclusion of the presentation. Following the webinar, you will receive a link to a survey. Once you have completed the survey, there will be a link to download the presentation slides. A recording of today's webinar will also be available for download on the IAPD website and in a follow-up email from GoToWebinar approximately 2 hours after this ends. Greg Hallam is the Director of Polycarbonate Products and Key Accounts at PLASKOLITE. With more than 20 years of experience in the plastics industry, he has worked in both the distributor and manufacturing side. With that, I would now like to turn the presentation over to Greg.
Hello, everyone. Thank you very much, Courtney, and welcome everyone. I hope everyone is being safe and practicing their social distancing and healthy out there. So without further ado, we'll get this thing kicked off. So really today, the goal of the presentation is to kind of get you a little background on the see-through products that are available for COVID applications, and then two, we'll go over the features and benefits of those particular products, and then afterward we will go through quite a few different applications and can dig into some of the applications a little bit further as well. So hopefully you guys will find it interesting, and look forward to your questions afterwards. So without let's get this show on the road. Okay, so really what we're looking at is three different types of thermoplastics that we'd be using for these applications. So it would be acrylic, which is a formed sheet of PMMA. I will go over the different types of acrylic products that are out there. It's really known for acrylic is for its optical clarity and UV stability. One of the key things is you don't have to pre-dry it if you're going to do some forming with it. So it's very formable. You don't need to pre-dry it. There are three different types that we'll review today, and we'll go over features and benefits of all. The next on the list is polycarbonate. Polycarbonate is formed through BPA and phosgene. It is extremely durable and has very high impact strength. We like to call it virtually indestructible. One of the things you'll find different about polycarbonate than the other two products, the acrylic and the PETG, is that the polycarbonate has a higher temperature rating, so it has a higher heat deflection temperature. So you can put that into different applications, whereas the other products you may not be able to put them in there due to heat deflection temperature. One of the kickers is that you do need to do a pre-drying before you would form. Last product on the list would be PETG. PETG is kind of almost like an in-between product between the acrylic and polycarbonate, where the polycarbonate is very durable and can take a punch. An acrylic doesn't quite have as high an impact strength. PETG would fall right kind of in between two of them, so it can take some of a punch. It's very thermoformable, and you can do a lot of different things with it. It has a low melt point. It does not require pre-drying. So there are some different things to each different product that make it unique and special, and we'll kind of go over those with you today in the features and benefits. Some of the real quick things you can look at from a technical properties perspective is tensile strength. The acrylic is a much more rigid product than the polycarbonate or the PETG. So standard acrylic product would have the highest tensile strength. Impact ISOD modulus. From an impact standpoint, polycarbonate would take the biggest punch, but it's also notch sensitive. PETG would be next, and acrylic would be last. Light transmission, acrylic would be the highest percentage of LT. chemical resistance, they're all really pretty good at it, at chemical resistance. It's just a matter of what chemicals really you're looking at. So some cleaning agents and some different fuel-based products and carbon-based products may not be as beneficial for polycarbonate as it would be for an acrylic or a PETG. So although they all say good on the list, some are better with some chemicals than others. So I would recommend you always take a look at the chemical compatibility lists. Last but not least, the line on the bottom is gamma stability. I'll get technical with you on the first slide. It's the gamma stability is for gamma sterilization and how people sometimes clean the different plastics. And the acrylic would be excellent, and PETG would be excellent, and the polycarbonate would just be average. So that may come more into play based on some of the COVID things going on in the world right now. So let's go into the acrylic side of this. So there are three different types of acrylic sheet that we see domestically here pretty regularly. All the acrylic sheet begins with a clear liquid called MMA or methyl methacrylate. What happens is that you do a pre-polymerization monomer in there, and you pour it into the mold or into the extruder, and then that would come out with a sheet. So there's three different types. One is called cell cast. In cell cast, you take the PMMA and you pour it basically into a large mold. So it's two big plates, and it's actually done one sheet at a time. So it's kind of unique. There are some specific characterization that we'll be able to go over, and some characteristics that are different between each one of these. But that's when you look at how the sheet is made. The cell cast is done one sheet at a time, and it's really poured into a giant mold. Extruded sheet is kind of similar to what people think when they start thinking about day in and day out extruded plastics. A monomer gets pushed through a die, and out the other end comes a sheet. So it literally is extruded through the die, comes out, it's cut, and is done. Again, it is a PMMA resin, a polymerized form of it. That would be your most economical side from a manufacturing standpoint in regard to the amount of labor and things like that. The extruded version would be the least amount of labor, whereas cell cast would be a lot more labor. Last on the list is continuous cast sheet. Again, it is a pre-polymerized monomer liquid, and it is poured into a die and rolled through stainless steel belts. So the neat thing about that one is it's actually the belt is about as long as a football field, just about. And as the sheet goes through the belt and down the belt, it is actually cured and cut and masked and pulled off the end in a continuous fashion. Hence the name continuous cast sheet. So again, these will be the three different types of acrylic products that we'll take a look at, and how they're manufactured does greatly impact the properties and what it is better used for, one versus another. So the cell cast acrylic, again, done liquid monomer poured into a big mold. As you can see, the picture on the right, those are two big glass plates. That is what the mold is consisted of. You put it in there, you press it together and generate some heat, and it actually cures into a sheet. It is the highest molecular weight sheet of the acrylic group, and it is the most chemically resistant one. Some of the things you're going to find that may be good or bad is that there's going to be a wide variety of thickness across the sheet. If you can imagine pouring it into a mold and pushing them together to generate a sheet can generate some variances and pressure points. So the thickness may vary across the sheet. You can make some of the thickest sheet available, though, is the cell cast acrylic sheet. It is the hardest sheet available as well. Some of the limitations also would be that you don't really get it much thinner than 1/8 inch, and the sheet sizes are limited based on the size of the plates. So it's limited to the molds and doesn't go real thin. Some of the interesting things is you can do a lot of different small batch custom colors with the product, because due to the fact that you're doing it basically 1 by 1 sheet, there's some lower minimums for custom colors than you would find from the extrusion or the continuous cast sheet. So from the extruded side, the extruded, if you want to call it, would be the most ductile or the softest surface finish. It would still be higher hardness than polycarbonate or PETG, but compared to cell cast or continuous cast, it would be the softest acrylic. It does have a very good a way of solvent setting for fabrication, so it's the fastest setup. Due to the fact that it's the least chemically resistant, when you put a bonding agent on it, like Weld-On or something like that, that would chemically bond the substrate to itself, that can attack it quicker because of the fact that it's less chemically resistant. The material, when it's extruded, comes in a vast array of different shapes and lengths and widths. You can get it in reels, you can get it in sheet, so you get roll, stock, and sheet. You can put different additives in it, so you can get it impact modified as well. The acrylic products in general are all UV stable, but some of the neat things that we can do with some of these are we can do very small run to size minimums. So thin gauge and run to size are two of the things that you should be thinking about when you're looking at some of the different acrylic products, especially with PLASKOLITE being able to do them at 1,000-pound minimums. It's really pretty attractive to do. So from 0.40 to 1 inch thick sheet for extruded. Again, putting material through a die and extrude it out the other side. Next on the list would be continuous cast acrylic. So this is a kind of a high molecular weight product, and it's really efficient for large production runs. So you know, that right now we have a pandemic going on, and the COVID-19, and we're able to do very large production runs of acrylic sheet, continuous cast acrylic sheet, due to the pandemic, and it's become very evident that it's much more user friendly to be doing large runs than smaller runs. So for large scale type products, this would be one of the ways to go that may be most efficient for you. You get excellent thickness on the tolerance, and the edges are very nice. Longer sheet lengths are available. So really, when you start looking at some of the different options here, superior edge quality, excellent optical clarity. The product is UV stable like all the other acrylics are as well, and its thickness is up to 354. So when you start looking at some of the bigger picture, it doesn't go into some of those thicker gauges of 1/2 inch or thicker that you see in some of the other products out there. So those are the three different types of acrylic. The next one on the list was the polycarbonate. So really, polycarbonate, it can be clear or with color. It is an extruded product, so it goes through an extruder and gets pushed through a screw and die. It is molten resin, so it comes in as pellets and comes out. It comes out through a die and then through a variety of chromed rolls. The material itself is UV stabilized, so it can see some UV, but you really, if you're going to have it in an outdoor application, you really want to put a thin layer of a UV cap on it to absorb the UV, and it's a co-extruded into the sheet, which means that the product actually is chemically bonded in there, so you can't wipe it off or rub it out. It's actually part of the sheet, so it's a UV cap, and you can get that on 1 or 2 sides. Another thing that you can find with the polycarbonate is that it can be laminated. So through heat and pressure, you can actually take a sheet of polycarbonate, you put an inner layer of TPU, which is a urethane-based product in between, another sheet of polycarbonate, and you can put it in a big bag, seal it, put it into what is called an autoclave, And you could do these in 2, 3, 4 levels and put it into the autoclave, you cook it and put pressure on it, and in a cycle time, based on thickness is how long the cycle would be, you would take it up to temperature and pressure and then slowly bring it back down, and when it's done, it comes out as a laminated sheet. So a lot of your bullet resistant products, containment grade products, you would find as a laminated sheet made of polycarbonate. So what is polycarbonate really good at? Again, I told you earlier, it's virtually unbreakable. So it's got great impact strength. You can thermoform it. You can cold bend it, so you don't have to put any heat on it. Say if you have a press brake and you want to put a 90-degree angle on it, you can do that through about 1/4 inch. Anything above that, you'd have to put a score behind it to get a good clean bend, but you can do it without putting any heat to it. The material has a higher heat deflection temperature. So, you know, if it's an application where there is going to be temperature involved and you're looking at a see-through product, the heat deflection temperature for the polycarbonate would be very, very beneficial to you in that one. As I mentioned earlier, the product is UV stable, but if you're going to be putting it in an outdoor application, you do want to put a UV cap on it. So UV stable just means that you can put it into an environment where it may see some odds and ends, periodical touches from UV, but if it's going to be continuous use outdoors, we would recommend you put a UV cap on it. The material is easy to fabricate. You know, you can router it, you know, die cut it, punch it, thermoform it, do lots of different things and glue it. There's lots of colors and textures available. And this, as well as the extruded product, can be made in sheets and or reels. So lots of versatility you'll find with the polycarbonate. Some of the different things you'll find with polycarbonate is it comes in a lot of different grades. So you could get general purpose, which is just our standard off the shelf clear, which has a good optical clarity to it. But if you have a really high optic application where you need something to look even less distorted or have less point defects, we have a specialty grade called optical clear. So it would be an OP grade of material. If you this would be the same with all the products, or at least with the extruded acrylic as well. If you have an area where you're worried about abrasion, you can put abrasion resistant coatings on polycarbonate. We put abrasion resistant coatings on extruded acrylic as well. And there's an FDA grade. So, you know, we have an FDA compliant product. Ironically, the PETG would have FDA compliance, and some of the acrylics do as well. So we have multiple applications where we're in grades that would meet FDA compliance. So next, the PETG. So PETG, again, is kind of like the middleman between acrylic and polycarbonate. It's really, really good for fabricating and doing thermoforming, so you can get really deep draw parts. It's very die cuttable, so when you start looking at some of the coronavirus applications, many people are doing the face masks out of 020 and 030 PETG. Precision molds, painting and silk screening, you can even directly print to it. You have a lot of different options there. PETG is FDA compliant and food safe. So again, when you start looking down the list, face shields, produce screens, food stands, salad bars. One thing though is that you need to keep PETG inside. It is non-UV stable, so it's an indoor only product. So I kind of hammered through a bunch of different things there for you. And really, when you step back, you kind of almost were like, wait a second, where do these all fall? So we put a kind of a little bit of a chart together for you so you can kind of see. And we can just do a quick overview of the different products as you go through there. So when you look at it, you go back through molecular weight. From the acrylic standpoint, the molecular weight would be cell cast first, continuous cast acrylic second, and extruded acrylic would be the lowest. And polycarbonate and PETG would kind of fall in the middle there. Thickness control, again, I'd mention, you know, if there's a tolerance needed on the sheet itself for thickness, Steer away from cell cast product. All the rest are all really, really good. Next on the list are optical properties. The cell cast acrylic and continuous cast acrylic are excellent. Extruded acrylic is good. We have good for polycarbonate because most of the applications you're going to see are general purpose. But if you wanted to get to excellent, you could actually get extremely clear polycarbonate type applications and products. Lots of windscreens for motorcycles and different ATV, UTV applications are there. Race car windshields. Lots of different things are made out of polycarbonate where a extremely high optical performance is needed. From Kellers, again, cell cast, if you're doing a lot of quick Kellers, that would be a very good one. Continuous cast is limited because, again, we want high volume type of orders on there. Extruded is, we have lots of different options due to the number of extrusion lines. So we have lots of options there, as well as polycarbonate. PETG is very limited in regard to Kellers. Sheet size and gauges, the cast products are limited. Extruded products are many. So the extruded acrylic, extruded polycarbonate, and extruded PETG, you have a lot of different sheet sizes and gauge options. So last, you get kind of into some of the fabrication portions of it that we had mentioned. So really, when you look at solvent bonding, the cell cast acrylic is the most chemically inert, so it's gonna be the hardest to do a solvent bond on. Which continuous cast acrylic would be next in line, but extruded acrylic would be very fast. Polycarbonate does do a nice job for some solvent adhesion. And PETG is not quite as user-friendly. So from shaping or thermoforming, as you can see, the extruded acrylic, polycarbonate, and PETG are all excellent. The continuous cast is good, and cell cast is fair. Flame polishing, again, you can read that one. One of the ones I always look at is that second to last one called surface resistance. You kind of start thinking, like, what does that mean? Well, really, I look at that as almost like is the durability of the surface in regards to scratching and marring. When you start looking at the polycarbonate versus acrylic, polycarbonate is much softer product, and PETG is as well than acrylic. So acrylic, although it doesn't take a punch as well, from a scratch or mar standpoint, it's a much more rigid product. So the surface resistance is going to be much higher for scratching and different things than would be your polycarbonate or PETG. And again, impact resistance, acrylic would be on the low end, PETG would be the next step up, and polycarbonate would be virtually indestructible and would have the highest impact rating overall. So that's really kind of real quick, just an overview of the products. What's good about them, what's bad about them, just kind of a quick, hey, these are what they are. And really now we start digging into some of the different COVID type markets. So let's start with the low-hanging fruit. The grocery stores, convenience stores. They're installing lots of these barriers. We have seen the barriers come in acrylic, PETG, polycarbonate. Some of the more permanent ones we'll see in a laminated polycarbonate because they may want there to be a higher realm of protection. So if there's medical involved or something like that, you may find that the thicker gauges are there. All these require some high optical clarity. Easy to clean, cut with standard tools. They're lightweight, easy to fabricate. People can pick them up, move them, do different things with them. Sheets can be run to size. So they can be cut out of a 4x8 sheet, so you can router them. You can do different things with them. So, you put down grocery stores and convenience stores, but the list, since I've have actually developed this presentation, is beginning to continue to grow. You start looking down the line at food processing plants, meat packing plants. So you see in the news that that Tyson Foods is closing. You see some of these other large food processing and meat packaging facilities. There is a whole new wave of barrier applications going to be coming at you. Be prepared. Again, any one of these products may work, but if there's FDA or NSF requirements, you need to make sure you're looking at those types of items if it's in a food processing or meat packing plant. But those are going to be ones that people are going to be needing very quick turnarounds. They're going to be needing to have barriers and dividers in between workstations to help people stay healthy and be able to stay open. If you look at the most recent, let's say Georgia, for example, just sent out their requirements to stay open or to open if it was a restaurant. One of the requirements is to have physical barriers between the seating. That doesn't mean that in between each individual seat, but if my table with my family was in one booth and your family was in the booth next to us, there technically should be a physical barrier partition in between the two of them. I really believe you're going to be seeing a whole new wave of barriers coming out in the very, very, very near future. Not only you're going to see what I just mentioned, but they're also going to want to kind of customize them as the public starts going back out into different markets. People are going to want to customize them by saying, hey, I may want to print on these things and have my logo on it. I may have directions on it. I may have some sort of information on it that might be helpful to our employees or to our customers, or both for that matter. So you're going to see a lot of customization. A lot of the products that went out first wave were general purpose polycarbonate and just regular extruded acrylic and PETG. What you may see on the next wave is printed ones, abrasion resistant products. I mean, the list can go on and on. So please be aware that these are all coming. It is very fluid and it's going to be continuously changing. Here's some other different barriers. These ones were put into a store as well, and it's just a small little square over a cashier's booth. Again, this is more than a convenience store, but start thinking about all the different applications. So you have convenience stores, you have grocery stores, but what happens when retail decides to open back up again? So when Bloomingdale says, okay, I need to have a partition or a barrier at every cash register in the store. I don't know how many have been into Bloomingdale's in New York City. There has to be 200 cashier locations in that particular building. They're everywhere. I mean, so that's one store out of a multitude in a town. So again, that'll be the next wave coming out as it comes out the other side. Restaurants. I mentioned earlier that you're talking about the sneezing, but what about sneeze guards, food service areas? There's going to be a lot more need for partitions and dividers and open air kitchens. If you have salad bars, anything like that, you're going to have some form of a barrier set up. So again, the list is huge when you start looking at the numbers and what you're really looking at and what the next wave is going to be. Didn't mention bank tellers, did I? People still go into the banks and they still have tellers in there. So most of those are open air as well. My guess is you will start seeing more and more partitions and dividers in banks for bank tellers and employees that they want a clear barrier. They want to be able to see through it. They want to be able to clean it. They want to be able to do different things with it. So these are again another one you're going to be looking at. So places are going to need to stay open. They're going to need to have a lot of these different these little different barriers to be able to have their doors and lights on. Here's one that people don't think a lot about, and that is transportation. So bus drivers, as well as passengers, are going to need to have barriers set up. So the bus drivers already, there are towns in Columbus, for example, where we're headquartered. They're not collecting fares. They're loading the buses from the back, which doesn't sound like much right now, but trust me, they want to have fares and they want to be getting paid. So they're going to come up with solutions on mass transit to do bus surrounds to be able to go and put in barriers to protect these drivers. So some of the rules behind that you'll get pushback on is a lot of people believe that there has to be an AS2 rating for that, and that is a surface rating. If the driver is looking through that, then yes, it would have to have a surface rating. But when you look at the side divider right here in the picture, you can see there's a cutout in that front, the front right portion of it. Well, what that does is if the driver doesn't look through that mirror or look through that window to look at the mirror, the front right mirror on the bus, then he does not need to have that AS2 requirement. It can be an AS4 or an AS5. So AS4 and AS5 would be general purpose polycarbonate would be an AS5, and abrasion resistant polycarbonate be an AS4. So when you start looking and thinking about some of the different conversations you can have, that right there is going to be an application that is in every single town across the country and will need to be addressed. So again, that's going to be low-hanging fruit. It's coming as the public gets back out. You're going to start seeing more and more applications and opportunities to be selling product into these types of transportation barriers. Another key one that people don't think about is when you're sitting on a bus and the seats are all one after another, the person sitting in front of you, if you sneeze or cough, or you're going to hit them in the back of the head, they will probably be putting partitions and dividers in between the seats right there, would be my guess. We haven't gotten that confirmed yet, but I'm going to be shocked if they wouldn't put those in there as well. So be talking to all your transportation, local transit authorities, rail, you name it. There will be opportunities to really do well and get a lot of sheets sold. We're all very familiar with the medical barriers, with medical applications. So contact with thermoplastic sheets is often approved if the sheet has an FDA grade. So we do have FDA compliant products. So you start looking at that happens to be a premature baby intubator that you're seeing in that particular applications, but we obviously will have face shields. So the face shield market, again, low hanging fruit, but as you start to go through some of this, you may start finding that people want different bells and whistles to the face shields. So, excuse me, they may want to have anti-fog or anti-static coating on the face shields. They may want to have them, they may want to have them post-coated or something with abrasion-resistant products if you start bending them or doing different things with them. So again, face shields, you have different protective personnel for caring for critically ill patients, like an intubator right there. That one's just a demonstration one, but you will see, if you scoured the internet, you would see a multitude of different types of intubators. Some are doing it out of thin gauge PETG, others are doing it out of acrylic and they're gluing it, others are doing it and cold bending it out of polycarbonate. So again, there are lots and lots of different uses and lots of different applications that you could be looking at. Please be looking and talking to different folks. Even when you start looking at close contact, that's an optometrist machine. So when you start talking about machine manufacturers, they may start adding these as standards to all their products. So again, lots and lots of places, lots and lots of things that are going to be coming up. One of the last final things that we wanted to talk to you all about were with the coronavirus being out there, there's a lot of discussion about what can I use to clean polycarbonate, acrylic, PETG, see-through products. My guess is you're going to find a lot of people do a lot of damage to these products by dumping all sorts of disinfectants, cleaning, very aggressive cleaning agents on them. And you'll probably get a lot of replacement orders because of that. But what you probably want to do is make sure that they are aware. Here's a real quick, how do I clean it? Obviously you can contact the manufacturer of the sheet products, but we have the brand on the left column, so it's whatever product that we're looking at, whether it be polycarbonate, acrylic, or PETG. You can see the manufacturer of the disinfectant or products that we could be used for cleaning. So there's a whole bunch of that are compatible. If you look down in the bottom part, we actually did put some in there that were non-compatible, just so that if you hear that name as well. I always say, hot water and soap and hot water is always the easiest way to go if you had to. That one works on all of them. But if you need to get after it with different cleaning agents, please look at this particular list and go through it, and you'll be able to kind of give your customer or end user a little bit of a education real fast on what they should or shouldn't be using. And don't get me wrong, you will find that you can send that list to someone, and within 5 minutes they'll send you over, hey, I'm using this, and it's way off the chart on what you're looking at and what would be compatible or not. So please beware to educate folks as they're cleaning and doing different things in the field, because we do want to make sure that they like our plastic products, because we want to keep them out in the field and keep using them, and obviously keep glass out of some of these applications as well. So I hope I didn't run through it too quick. If there are any questions, I would be delighted to start answering them.
Thank you, Greg. As a reminder, please submit any questions using your webinar toolbar. And we did have a couple come in during the presentation, so we can start with those while more come in. All right, the first question we got was towards the beginning. Are most COVID-19 applications non-impact acrylics? I know there are impact modified acrylics.
Yes. What we found is that most of the applications that we have seen out of the gate have been our standard, whether it be our continuous cast extrude or extruded acrylic products. There has not been any impact modified products really from an overall purchase side.
Okay, next question. What is the U.S. and global capacity of PMMA? What is the estimate of the usage for COVID-19, and do you know where that volume is coming from?
I honestly do not know the answer to that question. I can tell you that if you look domestically at all the acrylic manufacturers, every single one is pushed out with very extended lead times, just due to the influx in orders and what's going on from a capacity standpoint. So, ironically, if you look globally, the same exact thing hit in Europe, and I'm sure in Asia as well. So I don't know formal numbers to answer that question. I apologize. I'm sure there may be something in the chemical data, chem data or something like that from a PMMA monomer side. But from the capacity side, incoming has been significant in regard to overall what's happening with this pandemic.
Okay, a question in a similar vein, pretty specific though. What is the current lead time for large orders for 5 and 6 millimeter thick sheets?
5 and 6 millimeter sheet. You'll see a range from us from 12 to 14 weeks. If you scoured the you may find something in the 10-week range, but I would say anything from 10 weeks up has been going bill of fare from the acrylic side.
Okay, do you have a view on clear PVC in the market?
I do not. I would argue that the clear PVC from a chemical standpoint would be fine. It's not going to be as optically clear as the acrylic or polycarbonate or PETG. It may be able to, it may have some use in there, but I would say that it isn't going to be as good a product as the three reviewed with you today.
Do you think that abrasion-resistant coating will be used more often to help with cleaning?
I think what you're going to find is that as the public starts becoming more and more interacted with the products that you see out in the field, that the people are going to find that the material is going to get destroyed, whether it be from scratching, cracking, breaking, whatever it could be. And yes, the cleaning agents will also have an effect on it. With if you put an abrasion-resistant coating on it, you will have a higher chemical resistance factor. And I think when you add all of them together, you're going to find that people are going to want more permanent solutions, and the abrasion-resistant coating is going to be a big factor come next generation, kind of long-term type products that people are going to want to put in to some more critical applications.
What are your views on antimicrobial additives to see-through plastic?
Well, I think that there are antimicrobial products that some plastics have now, and that we're waiting for see-throughs to really start getting after it. You know, sooner or later, someone's going to develop one that is going to be pretty impressive to see. I would think that if you can come out with a with something like that, that it would be well received.
Which product will last best in a supermarket application?
Which product will last best in a supermarket application? Well, I'm an old school polycarbonate guy. I came from Bayer and then to Covestro. From a cracking standpoint, it will look better long term as polycarbonate. But when you start looking at it being brushed against, how many purses, jean jackets, you know, you name it, will be rubbed against that thing. An uncoated polycarbonate sheet might not look very pretty for very long. So the acrylic would be a better solution in that particular application. I would argue that most are putting in acrylic in that application just due to the cost factor more than anything. So I would say that I think they would both be well suited for different reasons. A lot of it, if it's you know, if it's going to be a spot where it's going to get rubbed up against and pushed and scratched, and the abrasion resistant portion of it would probably cause you more pain from the polycarbonate side than the acrylic side. So I would probably have to go with acrylic on this one. But I think both are very good solutions either way.
What is the lead time today for clear products?
It depends on the clear product. It depends on the gauge of some of the clear product as well. You know, you can go anywhere from for acrylic. You know, you can go for certain gauges to be 6-7 weeks. You know, if it's 2204 by 8s, that we do a continuous cast sheet that is, you know, it's 6-7 weeks lead time. If you're looking at extruded sheet, anywhere from 12 weeks on up. You go run to size or colors, that could be a lot of different variables. When you start looking at polycarbonate, we actually we had a big run early for thin gauge, but it seems like thin gauge isn't nearly as long as some of the other barrier type products that are being purchased. So thin gauge ones, 030 and 040, that you could be using for face shields. You know, that's not nearly as long a lead time as others. So I mean, there are several different options there, and lead times would go anywhere. Probably my guess would be from the low end on the 6-7 week side to the high end on 12 weeks plus.
Can impact modified acrylic be die cut, and could it be a good choice for face shields?
I don't believe it can be die cut, but I am not positive on that. I have never been asked that question. I'd have to ask my tech team, but I don't believe that can be die cut.
You're doing a great job on these questions. We've got some more coming in.
Okay, keep firing. If I don't know the answer, I won't tell you. Believe me, I'm trying my best here. Actually, I got the answer to that question. It's yes, die cut. Only and in thinner gauges only. So impact modified is die cuttable in thinner gauges only.
Okay, the next question I think is, in your opinion,
Bob and weave it.
Wishful thinking, with the reduction in oil prices, can we expect a price reduction in acrylic?
Actually, ironically, I would say no. When you start looking at the cost to manufacture these days, it's not necessarily in the monomer or anything on that end. It's more in the local cost that you're looking at. So one, you got to look at, we're expediting, film masking, pallets, all sorts of different things to try to stay up and keep up with demand. Two, our employees now no longer being paid just regular wages. They're getting paid a lot of different time for their overtime, and they're working tons of different hours. If it's acrylic specifically, acrylic is more of an acetone-based product, not a petroleum-based product. And I would argue, even from the polycarbonate side, the polycarbonate really it's not the petroleum itself. It's the byproduct of whether it's oil or natural gas is being processed. So as they get fracked, there is a byproduct of acetone and phenol and benzene, for that matter, and that is really those are really the byproducts that are used to come up with it. So if they're high or low in the market, then that usually drives your cost, just the resin side of it. But overall, there's a lot of different variables going on in regard to pricing wise, and my argument would be that no, nothing's going to come down. You're going to actually probably see it go the other direction, just due to the way the economy is. And again, our costs internally from all the plants, are going way up.
How often are you selling 1-inch extruded acrylic? My typical go-to is on 1 inches cast.
We can do the 1 inch. Cast is kind of a more of a regular one when you start getting to the thicker gauges. People buy 1-inch extrusion when they're concerned really about thickness consistency. That's really when you use the 1 inch for extruded versus cast.
Okay. Oh. I had an application, and the thin 0.020 can be die cut. So that was just a comment. Next question, what materials are suitable for laser cutting?
So for laser cutting, I believe they can all be used in laser cutting in some way, shape, or form. Masking can be can be an issue on some of them, so you got to make sure you watch that the mask bond to the substrate itself. But from the acrylic side, acrylic is popular with most of the lasers. A lot of the people that you see do different type of lettering will laser cut out the letters. PC is not as user friendly. It takes a little bit of a trick or two to get to do it. You can sometimes see a little bit of a burn on the edge. From the acrylic side, I'd recommend acrylic across the board.
Okay, we have one last question. And if you know the answer, do you know how this is going to affect the recycling market of polycarbonate and acrylic?
I do not know the answer to that. The acrylic and polycarbonate markets have not been very good from the recycling side, so I don't think it'll make it any worse, but hopefully it'll get better.
All right, Greg, you are awesome. Thank you so much for your time today. This concludes our presentation. As a reminder, you will receive a survey about today's presentation, but once you complete the survey, which is only 2 minutes long, there will be a link to download the presentation slides, so you will have access to this full presentation. And again, a recording of today's webinar will come from an email from GoToWebinar in about 2 hours, and it will also be available on the IAPD website webinar page. Thank you all so much for your time and participation today. We look forward to serving you on our next webinar.